And welcome back. So we're going to jump back in with spheres. We're actually going to skip this top problem up here. And I just want to talk about these composite figures down here with surface area and with volume. So if we look at both of these pictures, we notice I have a cylinder, and then instead of a sphere, we actually have a hemisphere. Well, earlier we did problems with spheres. We followed the formula. That was it. Easy peasy. But with hemispheres, it gets a little bit different. Because with hemispheres, we have to be careful because a hemisphere has a base. So that affects the surface area, but that does not affect the volume. So if we go to our formula chart, we're going to add in some formulas here. So for surface area of a hemisphere, and it might be a little bit tight to write, and that's okay, but a hemisphere has a base. A hemisphere has that flat circle that we could actually stack it on. So a hemisphere for lateral, it would be 2 pi r squared. It would be half of the sphere. But for total, it would be 3 pi r squared, which would include the base. So for a hemisphere, I have lateral and total because a hemisphere does have a base. Like if I draw a hemisphere, that's the base right there. So lateral would be 2 pi r squared, but then if I add in that circle for the base, that would be total would be 3 pi r squared. So hemispheres, I got to be a little bit more careful. Now, volume of a hemisphere, we don't have lateral and total with volume. So volume of a hemisphere would just be half of the sphere. So instead of 4/3 pi r cubed, it would be 2/3 pi r cubed. So if we go back and we look at those two problems, for surface area, if I go from top to bottom looking at this shape right here, I see a hemisphere and then I see a cylinder. And I need to be careful because am I going to include, is this part on the surface for the hemisphere? Like if I were going to paint this, would I actually paint that part? Well, no. So I would just be using the lateral for the hemisphere. And if we go back and look at our chart, lateral for a hemisphere is 2 pi r squared. So to find the formula for the top, that would be 2 pi r squared. And then if I take a look at this cylinder, well, I don't want to include that base for the cylinder either. So I like to work my way top to bottom. So if I ask, what's that wraparound? Well, if I have a cylinder and I find that wraparound, that would be 2 pi RH. That would be lateral for the cylinder as well. So surface area for that cylinder would be 2 pi RH. But if I think about this surface area, so I know it's lateral for the hemisphere, it's a wraparound for the hemisphere, it's a wraparound for the cylinder, but then I can't forget this base here on the bottom. So how do we find the area of that base? Well, that's just a circle. How do we find area of a circle? Pi r squared. Sometimes in composite figure problems with surface area, we have to make up our own formulas. So I had to do lateral of the hemisphere, lateral of the cylinder, and then I just added in the one base. So it was easier to do lateral and then add in the parts that I was missing versus trying to do total and then take out all of these extra pieces that I don't need. So if we look at this, they all have the same radius. So they all have that same circle, that same base throughout. 12 is pointing to the whole thing, and remember that the radius is just half. So if 12 is the diameter, that's the whole, the radius would be half of 12, which is just 6. So coming back up here, so 2 pi 6 squared. Remember we do exponents first, so 6 squared would be 36, and then 2 times 36 would be 72 pi. So we're leaving it in terms of pi, and then we're just going to practice our mental math skills. So 6 squared exponents first, 36 times 2, 72 pi. Okay, so now for the lateral part of a cylinder, that would be 2 pi, r is still 6, and h for my cylinder is 9. So 6 times 9 is 54, and then if we multiply that by 2 or just double it, that would be 108 pi. And then for the base, for the bottom, for the circle on the bottom, that would be pi r squared. So pi 6 squared would be 36 pi. And then if we add all of those together, that's going to give us the total surface area for the shape. So I'm going to give you a minute to add all of those up. And that would make our surface area 216 pi inches squared. That's it. Now, if it said round to the nearest tenth, then we would have to go to the calculator and like actually type in 216 pi. So if we round to the nearest tenth, that would be about 678.58 inches squared. But our default's going to be in terms of pi unless the problem says otherwise. So that's it. That's how we found the surface area. Now, let's just say that I wanted to double the dimensions. Like I wanted to change the 9 to 18 and I want to change the 12 to 24. If you actually remember, we have a shortcut. If you're doubling the dimensions, then the area would be times 2 times 2, and so my surface area would just be times 4. Now, we're not actually doubling the dimensions. I just want to prove a point that if we do slightly adjust a problem with the dimensions, if I already have the answer, I can just multiply it by 2 squared, which would be times 4 to get the answer. So just keeping that in mind is that sometimes in a problem we make a minor change, but we don't have to redo everything. We can just adjust from there. That comes from the formula like this formula. So I would take the original surface area, which is 216 pi, and then multiply it by 2 times 2. Anyways, moving on to volume. So what I really have here is like a bowl. So I have a cylinder, and then they took out a hemisphere to make this a serving bowl. So volume of a hemisphere. If we go look at our formula chart for volume of a hemisphere, we should get volume equals 2/3 pi r cubed. You know, that's the hemisphere, but then I also have the cylinder. So volume of a cylinder would be capital BH. So it doesn't really matter which one you do first. Let's just go ahead and let's start with this volume of the hemisphere. So volume of the hemisphere, all I need is the radius, which they told me was 3 because it's pointing to the half. So 3 cubed, I need to be careful here because 3 cubed is 3 times 3 times 3, which is 27. And then if I do 2/3 of that, there's actually this little trick that I like to do with fractions. And it's where we divide by the denominator and then we multiply by the numerator. So what's 27 divided by 3? That's 9. And then 9 times 2 is 18 pi. So you divide by what you have in the denominator and then you multiply by what you have in the numerator. So if you have 27 times 2/3, I do 27 divided by 3 and then I multiply it by 2. So like 27 divided by 3 was 9, 9 times 2 is 18. You get the same thing if you do like 27 times 2/3 in the calculator. Okay, now that's our hemisphere, but we have our cylinder as well. So if you think back, what did capital B stand for? And if we go look at our formula chart, capital B was the area of our base. And if we have a cylinder, ask yourself, what shape is the base in a cylinder? Well, the base of a cylinder is just a circle. So to find capital B, I'm going to do pi r squared. So the radius was just 3, so it's still the same radius. So pi times 3 squared would make the area of the base, or the area of that circle, 9 pi. So now that I know capital B, I can come back over here. I found the area of the base. The area of the base is going to be 9 pi. And then h would be 5. So 9 times 5 would make that 45 pi. Now, this is where I need to be careful, because on the last one, we were adding up all of the parts. But on this one, if I have a bowl, I have a cylinder, and I'm taking out the hemisphere, which means that I don't want to add these. In this case, I want to subtract. If we have a hole, if we're taking something out, we would subtract. So what's 45 pi minus 18 pi? Well, that would just be 27 pi feet cubed, because it's volume. And that's it. So on the previous problem, I talked about like, what if we doubled the dimensions? And if we doubled the dimensions, the area would change by 4, because it would be 2 times 2. For volume, I'd have to be careful, because volume would be units cubed. So it'd be 2 times 2 times 2, which would make that times 8. Now, it didn't ask us that. That was just a random sidebar as we continue to talk about surface area and volume. Remember that you have some shortcuts in there. So that's it for surface area and volume of spheres and hemispheres. Be sure to add those formulas to your colored piece of paper, and then good luck with your practice.